Hi, this is ME 1770, Section H, Group 7, and this is our over-the-coffee presentation.
Alright, so we're just going to talk about how we started, what we did. So we started off looking at last semester's EGLIDE. Is that it? EGLIDE 5000. This is what their EGLIDE looked like to us. Then we looked at it and thought about possible improvements for our EGLIDE, right? So
the whole idea behind our project, we first started off with our original proposal.
What was it? A segue mechanism. So the recursive sensors, tilt mechanism. So basically, you tilt this way on the EGLIDE, and it's going to go forward, but you it slows down, goes the other way, right?
Right. And another major improvement we're talking about was we wanted to get rid of the controller that they had. And we wanted to, I remember last year's EGLIDE was mainly for off-roading. We
were also trying to make it more maneuverable, so we got 2 wheels, and we came up with like a 2 in-wheel mechanism.
The original design had 2 wheels and worked very much the way a Segway did, which that all changed when we started to meet with the other groups. Girl will talk about the next part.
And I think it was a theme of our project that at every stage there were evolutions to the design. And the stage was definitely meeting with the other groups in our team and incorporating their ideas with our ideas to improve the project. Skateboard. And as we met with the other groups, we added features and we also changed other features.
Yeah. This is how we came up with to begin with. We met with the other groups from the other sections and we talked things over, and nice ideas. Section A had, Section I had
Section H had excellent ideas.
We had excellent. Section M came up with an in-wheel motor, so that way we wouldn't have to have like a separate motor box. Section I had the idea of adding a bunch of add-ons to the thing, because we had the problem where we had simplified it to a point where, so they came up with a nice idea of adding extra features for our, like a GoPro camera, a foot brace, headlights, charging port.
Yeah.
So in addition to all those features, we also changed a little bit in the way the attachment with for a skateboard truck. So if the battery died or you didn't want the motor, you could attach the skateboard connection and just use it like a regular skateboard.
So then we came up with this design. We went back to the 4-wheel mechanism, turned it into sort of like it still had the trim, but it also had an in-wheel motor. So basically, it moves in the direction you're tilting the sections. Everyone was on board with the idea, and we started moving with that. Yeah.
So that figured out, and we decided what we were going to do as Group 7. We met with Dr. Dixit and got our final proposal approved.
Yeah. So the things he liked.
That was really when it came to us that we should be implementing parts from the last EGLIDE and putting into this one.
He liked that idea that we were trying to recycle a lot of like a client manufacturer point of view. If you're going to change the design for something, you want to reuse many parts, so you don't have to scrap those parts basically. So that was our aim, to reuse some parts. He also liked the segue mechanism, but the problem was the counterweight, and but with the board, that sort of solved, because you can set your foot on the board and balance your weight on the board, and with the gyroscope, it sort of we decided to move with those ideas. Those were main action items for us.
So from that point, once we had our final proposal approved, we moved into the part model off each by hand sketching our models, the isometrics. Then we did multi-views for each of those, and then we moved into an inventor part files. Jack, why don't you talk about your parts?
Well, our group mainly focused on we had the gyroscope, the whole idea of that, and also the rear axle that we were supposed to put it on.
The whole suspension.
And and I took care of the gyroscope with the casing over it, and how it works is the little module, every time the module rotates with it, and the sensor can pick it up inside it, and that connects right to the processor. We also did the processor, and that kind of controls how the board moves and it connects the process to the motor, which tells the motor what to do.
And I think it's important to realize that even to keep an area of practicality in our design. So, for example, like you were saying, you actually thought through the gyroscope design. So, fancy CAD model, but also I designed the pressure sensor, and I remember from ME 3710 that we learned how Wheatstone bridges. I tried to make the outer physical design consistent with what would be needed to implement an actual pressure sensor. And I think there are more examples of that.
So, going off what Carell said, a big part of our project was we talked about putting rocket boosters onto the board.
Very interesting.
But the practicality of it was probably was not realistic. So to adjust for that, that was a big part of the project, was adjustment. I had to adjust a lot over the project. So at first I had to CAD symbols, I had to do a truck, but that really changed when we met with the other groups a lot and found out I was doing a skateboard truck, not a truck for the EGLIDE, with the dynamics of how the project changed.
A lot of things changed around our Inventor or AutoCAD, so we didn't have the kind of functions we can use. And as that evolved and our more complicated stuff than we imagined, and we can make it look a lot more realistic. That's why initially we came up with a truck, but when we talked to the other groups and putting an in-wheel motor into the truck, it wouldn't work the way we wanted it to. So we decided to just basically make a move where we saved all our parts and no one had to go back and change it, but we basically added features. Josh's truck, which was initially meant to be just for suspension, just instead of the original longboard truck, and then we had a separate axle and a truck with the motor, right?
Yeah, and I think that the importance of incremental design is clearly something we're taking away from this project and learning in this class.
So effectively, I used to be doing a lot of work on my own, but then with a group like our group, we all worked well, and that really helped me realize.
And another thing that I learned, and Dr. Dixon stressed over a lot, was what you're talking about earlier, the dynamic of the whole project. It was always constantly, there was a back and forth between us and then even the group members and then Dr. Dixon, which was our client in this case. And we just went back and forth. You know, we had our idea of how we wanted to, or how we thought the project would go, and we brought it to him. Once we had to bring it back, and it's just like.
The thing I took away from the project was, as Aditya touched on, the importance of good tools in the design process. So with Inventor,
I think one of the most is communicating with not just among us, but with the other leaders as well. The other sections, if we hadn't communicated with them along the way and made sure everyone knew everyone else's dimensions, everyone else's units, what everyone else's parts looked like, we kept sharing everything. There was Dropbox accounts, Google Drive accounts. If we didn't know what every other person was doing, because there are 70 parts in it, and 5 people, I think it would have been really hard to put things together. But see, since we communicated along the way, maybe every week, when it finally came to putting things together, it took maybe like half an hour, and we had our board ready instantly. It just clicked. We didn't have to go back to the drawing board, and we kept that together. Thanks for watching, guys. Thanks for your time.